Hello, and welcome everybody to this Copernicus Marine Service training workshop dedicated for the Mediterranean Sea. My name is Fabrice Messal. I'm a UX and capacity development manager at Mercator Ocean International. And I will be accompanied by Ergane Fouchet from Noveltis to moderate this session. Hello, Ergane.
Hi, Fabrice. Hi, everyone. Thank you all for being here today. So as Fabrice said, my name is Ergane Fouchet. I work at Noveltis as an ocean engineer. And so I'm very happy to present this session today.
Okay, so let's dive directly in the session. And I think you have some technical information and the agenda to present. Ergane?
Yes. So the first thing to know is that all the material that has been developed for this workshop, they are all available in one single platform. This is what we call the Padlet, and you will find the link to this Padlet in the chat. So in this Padlet, in the web page, you can find the agenda of the workshop, the participant manual, plenty of videos on how to access the products, how to use the Copernicus Marine Service. You will also find the link to the practical exercises that we will present tomorrow. You will find the use cases and some presentations on the product. That's it for the Padlet. As
and I
said,
think there is also a link to a map, no? To pin their location, no?
Yes.
Yes, if they want, if you want, you can go directly on the Padlet, and there is a functionality to pin your location. So as it is, we can see the dissemination of all the participants on the Mediterranean basin, and perhaps in Europe in general. So it will be very cool to have this map of the participants. And then
as you want, we have a platform that we use for you to ask your questions. It's called Slido, and again, the link to the Slido will be sent in the chat. You can also use the chat on Zoom, but we would prefer you to ask your questions on Slido. You can react or do some small talk on the Zoom, but ask your question on Slido. And do not hesitate to ask your questions during the presentation, because after each presentation, we will take time to answer the questions. So do not hesitate. And here is the agenda of today's session. So now we're having the welcome and agenda presentation. Right after this presentation, Fabrice is going to present you the Copernicus Marine Service. Then we will have some overviews on the products. We will have a presentation of the satellite observation products, the in-situ products, and the model products. Then we're going to have 3 user testimonies for you to learn how the Copernicus Marine Service products are used. You will have a presentation of the user corner and the e-learning material available. At the end, I will present you the program of tomorrow's session, so workshop day 2. And at the end of this session, we will have some extra time for you to ask your questions to the experts. So we will split into different breakout rooms, and you will be able to choose the expert you want to talk to. So we will explain this later, but remember that if you have time, you can stay with us and ask your questions.
Okay.
That's it. And I think now Fabrice will introduce us to the Copernicus Marine Service.
Yes.
The floor is yours.
Thank you to keep your microphone muted during the webinar. Thank you. So let's start with this introduction to the Copernicus Marine Service. So it's quite challenging because I have only 5 minutes to introduce you to this huge program and this huge service. So let's start. So the Copernicus program, it's the program dedicated to Earth observation. And this is on behalf of the European Commission to develop this Earth observation capacity for Europe, developing infrastructure and service to deal with the data and to disseminate all the data produced by these infrastructures. So you can find the 6 services on the slide, and the Copernicus Marine Service is dealing with the Marine Environment Monitoring Service. Okay, what you can find on the service, you can find data on the blue ocean, what we call the blue ocean, means physical information of the state of the ocean. On the white ocean, with sea ice products, for example, and the green ocean with biogeochemical viable accessible on the service. There is a single access point, which is the Copernicus Marine Service website, so marine.copernicus.eu. On this website, you will have access to the online catalog with all the products available. There is more than 300 scientifically qualified products. All the roadmap of this service is user-driven, so we try to collect feedback and user needs to prepare the next release of the catalog. All the data have a common format, which is very simple to compare the data or to work with the different kind of data. And this is an open and free services, so you have just to be registered to access all the different products and tools provided on the website. Regarding the data sets available on the catalog, you will find different data sources. You will find model data, in situ data, satellite data with different temporal coverage, with reanalysis over the 25 years in the past, near real-time data, daily, hourly updated. And thanks to the model data, you can find some up to 5 or 10 days forecast. There is different geographical coverage. We have the global one, but also the different European basin. So if you choose to filter on the catalog the products by region, you can choose directly to filter on the Mediterranean Sea and see all the products available on this region. More than just a data provider, yes, we provide also information as like the Ocean State Report summary. We have ocean monitoring indicators accessible on the web portal, and we have 3 kinds of visualization tools dedicated to different users, from the beginner to the experts user, with, for example, the MyOcean Pro viewer, but you will have a demo tomorrow. And all these data are accessible and available to provide information and products for different sectors of the society, for the environment, and for the what we call the blue economy. So as you can see, we can disseminate data for the ocean health, to monitor marine food, to help to the implementation of the European policies, etc. And you will have some example with use cases example. We try to provide also a lot of e-learning material to help people and to support them in the use of the data. So how to download the data, the different data access available, which data will be relevant for my daily job. So we have a strong user support to help you in this daily work. We try to organize a lot of webinars and training workshops to encourage people and to give visibility to all of these products. We participate to a massive open course, different courses, organize, and we also participate to hackathons, or we organize our own hackathons. You can contact us or follow us directly on social media, on Twitter, on LinkedIn, and YouTube channel. All the recording session of the previous webinars or e-learning material videos are available on our YouTube channel, so don't hesitate to have a look on it. Thank you.
Thank you, Fabrice. So now that we know more about the Copernicus Marine Service, we can dive into the products overview, starting with satellite observation products and Andrea Pisano from the Italian National Research Council. Hi, Andrea. Thank you for being here. You can start sharing your screen.
Hi, yes, of course. Well, is it okay? May I start?
Yes, sure.
Okay. Good morning to all of you. I am Andrea Pisano, researchers at the Italian National Research Council, Institute of Marine Sciences, and I am presently responsible of the Sea Surface Temperature Thematic Assembly Center within the Copernicus Marine Service. And with the contribution of Emanuela Clementi and Daniela, I'm going to present you an overview of the satellite products. I prepared this talk with the aim to give you some basic information and elements that can guide you throughout the catalog of the Copernicus Marine Service. So I will present you an overview of the tags, the different types of satellite data, and a focus on three oceanic variables, namely the sea surface temperature, sea level, and ocean color. Well, the Copernicus Marine Service provides regular, systematic, and state-of-the-art reference information on the physical and biogeochemical ocean state, covering the global ocean and the European regional seas. The backbone of this service relies on a distributed architecture built on production centers for observation, known as thematic assembly centers, and modeling forecasting centers, and a marine information system for the collection and dissemination of data to the users. I will focus on tags. There are 8 tags, 6 satellites organized by ocean variables, namely sea level, ocean color, sea surface temperature, wave and wind, plus an in situ tag and a multi-obs. TAC are primarily based on satellite observation, and remember that detailed information for each product is reported in the product user manual and quality information document. The tags generate validated data that are directly usable for downstream application, but are also used by the MFCs, the model forecasting centers. The offer of that products is very rich and cover the blue, white, and green ocean. Key message is that the data are provided in near real time, namely, a product is available from a few hours to a 1 day delay, and this production is mainly thought for operational use. And a multi-year production that provides a longer time series of the same variable, typically covering a period from 10 to 45 years, and it is thought for climate studies and generally provides data of higher quality. Okay, then, as shown from the next slide, you will find satellite data provided as level 3 and level 4 files. What does it mean? Well, there are different levels of satellite products. The first one is the level 2, which is the data provided on the native satellite SWOT grid, while the level 3 uncollated is the level 2 regridded onto a regular latitude-longitude grid. These files are not very useful for users, and indeed are not provided through Copernicus. While more useful is the level 3 collated file, as an example is shown in this figure, and it is a single sensor product based on collated level 3U data, typically provided as daily composite data. Is the merging of more level 3U data. The next level is known as level 3S, is a merged multi-sensor, so from different satellite sensors product. And finally, the level 4 is the gap-free, not data void product built upon the level 3S. I recall you that satellite sensor from visible to infrared and microwave cannot see through clouds and or rain, so they generally present data voids. And the final product, the level 4, is more useful for applications. So moving to the sea surface temperature TAC, well, this TAC is in charge of the near real-time and multi-year production of level 3S and level 4 SST products, covering the global ocean and the European regional seas. Just an overview of how SST is measured. Well, infrared and microwave sensor measure the radiation emitted from the sea surface of the ocean, which will approximate the black body radiation law. There are different types of SST. I recall you the skin, subskin, and foundation. The skin is the temperature measured by an infrared sensor, and it is representative of a depth of the first micron of the sea surface. Below the skin, there is the subskin, typically measured from microwave sensor. Its depth is about the first millimeter level from the sea surface, and the foundation SST is the temperature free of diurnal warming at a depth of 10 meters. The products specifically provided for the Mediterranean Sea, well, you can find 4 main products. 3 provided within the near real-time family, and 1 provided within the reprocess family. Within the near real-time family, we provide a level 3S and a level 4 SST field, as shown in the 2 figures, derived from different infrared sensors and representative of nighttime SST values. The spatial resolution, there are 2 spatial resolutions. You can choose among a 6 kilometer and 1 kilometer product. The temporal coverage spans from 2008 to present. Concerning the reprocessed production, there is a longer version that covers the period from 1988 to present at 4 kilometer resolution. The variable provided is always a foundation SST. Last year, we released a new SST product, specifically a subskin SST, which provides hourly mean map over the Mediterranean Sea. This is an animation built by using 24 consecutive hours. This product is more recent. Indeed, it covers the period from 2019 to present at about 6 kilometer resolution, and can be useful for estimate the surface heat fluxes and also the diurnal warming amplitude. Now moving to the sea level TAC. Well, this TAC provides sea level information and derived quantities from radar altimeters. So we move from infrared to radar sensors. The altimeter measures the altimeter range, which is the relative distance between the satellite and the free surface of the ocean. Then, provided knowledge of the geoid, which gives the mean sea level under the effect of gravity and Earth's rotation, it is possible to derive the absolute dynamic topography, which is an important variable for the ocean dynamical processes. Other important variables are the mean dynamic topography, which is the temporal mean of ADT, and the sea level anomaly. Concerning the offer of the sea level product over the Mediterranean Sea, there are 4 main products, 2 near real time and 2 reprocessed, that provide 2 main variables, the sea surface height and geostrophic velocities. Well, similarly to SST data, these variables are provided as level 3C files and level 4, namely gap-free or optimally interpolated. The spatial resolutions vary from 7 kilometers for the level 3 file to about 12 kilometers for the level 4 data. The temporal coverage span from 2019 to present for the near real-time production, and from 1992 to present, actually to 2020, for the reprocessed product. Another important product, useful product, is the mean dynamic topography, which is a static level 4 field. Now, as last variable, the ocean color. Here we move to the visible class of sensor. For ocean colors is the study of physical and biological seawater quantities derived by visible radiometers. The basic principle is that the solar radiation penetrates the top layer of the water column, interacts with organic and inorganic matter through the absorption and scattering processes, and then reaches the satellite sensor, bringing the physical and biological information. Within the Copernicus catalog, these quantities are provided divided into two families. Optics and biological quantities. Within the optics, I recall you the reflectance at different wavelength, the attenuation coefficient of the line of light known as KD for 4090, the inherent optical properties and the color dissolved matter. While within the biological family, the chlorophyll concentration and phytoplankton functional types, PFT, namely 9 phytoplankton groups. Well, concerning the products within the biological family, biofamily, the Ocean Color Tag provides 4 main products, 2 near real time and 2 reprocess that provide you two main variables, chlorophyll A concentration and PFT. As for the other variables, you can find level 3S and level 4 fields. In this case, the spatial resolution varies from 300 meters to up to 1 kilometer. The temporal resolution is daily, but also monthly, and the temporal coverage spans from 2016 for the near real-time production to present, and from 1997 to 2021 for the reprocessed family. Concerning the optics family, there are 3 main products, 2 near real time and 1 reprocess that provide variables like KD 490, the inherent optical properties, and so on. They are provided as level 3 and level 4 fields with similar spatial and temporal resolution. So, well, basically that's all from my side. I put in this slide 3 main references for the argument that treat the arguments presented here. So,
thank you, Andrea.
Thanks.
Thank you.
Thank you very much.
So we have a lot of questions. I will share my screen. If you let me. Yes, thank you, Andrea. So we have a lot of questions for you, Andrea, about the satellite data. So we can start with one question to be quick, and I propose to the participant to meet Andrea during the breakout room at the end of the workshop. We will have 30 minutes with direct discussion, and we will keep the question, and we will ask all these questions to Andrea during this session. So just one question. I would like to detect, so question from Lauren, I would like to detect SST extreme events. Will the satellite nighttime data distort my results?
Well, it depends on what do you mean by extreme events? Because there are different type of extreme events. I would say that nighttime data, daily nighttime data, can be used to detect marine heat waves. But if you want to increase the temporal resolution, you should use, you can use hourly data to estimate the diurnal warming amplitude.
Okay. So thank you, Andrea. I propose to move to the next presentation. And again, don't be afraid. We keep all the questions, and Andrea will try to answer the questions in the breakout room at the end of all the presentation. Okay. Thank you, Andrea. So let's move now to the next presentation. So this is a presentation by Maria Sotiropoulou about in situ products.
Hello from me as well.
Hello, so, Maria. You can share your screen.
Let me see. Not yet.
Okay, sorry. Yes, okay. It's fine. Perfect.
Well, so as you already have introduced me, I am Maria Sotiropoulou. I am software engineer at HCMR, at JellyX Center for Marine Research. And today I am going to present you the in situ component of Copernicus Marine Service. I am going to start with a motivation quote from Fouchet et al. Without sufficient observations, useful prediction will likely never be possible. Models will evolve and improve, but without data will be untestable, and observations not taken today are lost forever. So we speak of in situ data, in situ observations that are describing a complex ocean, which involves many different processes in different spatial and temporal coverage. So a multi-platform approach is needed in order to observe the different systems in coastal areas, in deep seas, trajectories, and fixed positions. And here comes in situ thematic assembly center, which has as its main objectives to collect multi-source, multi-platform, heterogeneous data and perform consistent quality control procedures and distribute data in a common format, let's say FOR specifically, following specific naming conventions and metadata requirements, and all these being always well documented and up to date. Thus, distributing data in near real time within less than 24 hours to the Copernicus Marine Forecasting Centers to be used for assimilation into their numerical ocean models, and also to supply the marine forecasting centers and downstream users with reprocessed 25 to 50-year products in delayed mode. In addition to the near real-time products, these delayed mode products are useful for model validation or assimilation in ocean reanalysis and climate studies. Here I'm going to present you some very important characteristics that describe the in situ thematic assembly center. There are seven components, the global and 6 regions, Mediterranean included, which are engaged to provide their expertise in their region of operation. There is also a strong collaboration with international initiatives like Eurobus, SeaDataNet, and Emonden. The data are provided under an open and free policy. Someone asked also in the chat before, a while ago. There is a unique access point, the Copernicus Marine Service Catalog, the FTP service, which requires a free registration in order to have access to the data. The data there are provided in HDF format, and in order to ease user navigation and search, the available data are described by index files. The data are distributed into 2 product families, the reprocessed and the near real-time products. And the reprocessed products are updated twice per year in a global scope and provide delayed mode quality control, they consider one specific parameter category, either waves or biogeochemical or temperature and salinity currents or carbon. And on the other side, the near real-time products are updated much more regularly, up to every hour when the platforms are recording in a high frequency. The scope is both global and regional, so there is also a dedicated near real-time product only for Mediterranean region. This product contains both delayed mode and near real-time quality control when delayed mode quality control is not available. And the parameters, main topic of these files is whatever the platform is recording, since we have a platform-oriented system. All these products are extensively described in a product user manual, providing information of the products and data files, and in the quality information documents that are describing the quality control procedures that are applied both in near real time and delayed mode. So my next slide is a little more technical, but it is important to have in mind the folder structure of the Mediterranean in situ near real-time product, which applies to the rest of these in situ products as well. The product for the MED is the in situ MED near real-time NRT observations 013-035, which you can find in the Copernicus Marine Service catalog. Initially, I have to comment that the name of the product is going to change after November 2022. The rest of the structure and the files format will remain the same. So there is a latest subdirectory with data covering the latest 30 days in files provided per day per platform. Also, for the latest 5 years, there is a subdirectory containing a file per month per platform, and the history subdirectory, which contains one file per platform with all the data that this platform has recorded during its operation. For each of these groups of data, there is an index file providing a list of all available files in the respective group. Index latest, index monthly, and index history files have the same format and provide information on the file names and the respective geospatial and temporal coverage and the contained parameters. So you can use these files to filter out the data that are of your interest. Apart from this, also there is the index platform file, which provides information on each platform available in general in the specific in situ near real-time product. And one more slide with some technical details. What information is the naming of each file providing? In general, we are using a specific file naming convention. The first part of the file names is describing the platform. The first four basically separated by underscore. So the first one, the first diagram is describing the region that is responsive for the creation of the data file. The second one is describing the file type, whether it is time series, profile, total velocities, radar velocities, or wave spectral data. The third diagram is describing the data type and the platform that is recording these observations. And the fourth part is the code of the platform, which is a unique identifier for this platform. So the latest files are followed by the date of the day of the data that they contain, the monthly by the month, and the history do not provide any date because they have everything inside, although sometimes there might be an additional part describing, for example, different time samplings. So in the next section, I will provide you some information on the in situ evolution and how we keep track of our progress. Here you can find the Marine in situ website with many useful information on the in situ near real-time products, including Mediterranean. You can find all the latest documentation from the product user manual to the region spatial definition and the full list of the parameters that are distributed in the in situ component. Regarding the parameters, if you find that an important parameter is missing, please contact us in order to extend this list and the product datasets accordingly. You can also find information on all the quality control procedures applied, as well as some useful code. Also, in the dashboard section, there is an interactive map where you can see the latest positions of the platforms available and filter out the cases of your interest. In this instance, you can see the latest 30 days of active platforms on a global scale, Mediterranean included. And in the next slide, the Mediterranean region has been selected, where you can also check some initial metadata information on the platforms of your interest, or even choose to download the data. This button provides direct links to the data files in the Copernicus Marine Service Catalog. So apart from this section, we are constantly monitoring in situ progress with specific key performance indicators. For example, the delay of arrival, which is basically the delay in the latest data record that is provided in a file compared to when the data are available in the Copernicus Marine Service, the data quality, the number of platforms, the number of providers and files. And here we also provide an in situ products catalog with some additional filters where you can search which product contains the data of your interest. And finally, there is the providers catalog where the users and especially the data providers can find information on the engagement of users for its provider and their data. Clicking on the stats for each provider, a details catalog is opening, providing information on the platforms that this provider is distributing in the in situ component of Copernicus Marine Service, and some statistics on the user engagement on these platforms as well. So this is all from me. Thank you for your attention. And any questions?
Thank you, Maria. Yes, we have some question for you, at least one.
Okay.
Can I share my screen?
Yes.
Yes. Okay, thank you. So, are in situ data available as open datasets for non-European users for validation purposes with local measurements?
Okay, all in situ data are available. They are open and free, as I have already said in my presentation. So there's only a free registration that is needed from Copernicus Marine Service. Apart from that, you are free to download whenever you are located, wherever.
Okay, there is another question. Do you offer standardized routines for QC and QA in NRT?
Yes, and you can find a detailed description of what procedures are applied or on our near real-time products in the documentation section that I have shown just 2 slides from the end of my presentation. Yeah. So yes, I don't think I can answer with all the routines that are applied. Yes, but there are automatic ranges checks, spike tests, stack values checks, and I am forgetting something. These are for sure standard procedures that are applied, but you can find the detailed procedures in the documents.
Yes, thank you. Okay, thank you, Maria. And for the participants who asked the question on the Slido and on the chat, video replay will be available soon after the workshop on the Copernicus Marine YouTube channel. Don't be worried about that. Let's continue again.
Yes, we're going on with our last product presentation. We're welcoming Emanuela Clementi from the Euro-Mediterranean Center on Climate Change, and she's going to present us the model products. Hi, Emanuela.
Hi, everybody.
Thank you. The floor is yours.
Thank you. Okay, I guess you can see my screen.
Yes, thank you.
Okay, so I'm Emanuela Clementi. I'm a scientist at CMCC, the Euro-Mediterranean Center on Climate Change, and I'm going to present you the model product overview. Sorry, I would like to... the model products for the Mediterranean Sea are provided by the Mediterranean Monitoring and Forecasting Center, so-called MED-MFC, which is one of the 7 MFC's monitoring and forecasting centers within Copernicus. It is led by CMCC, which is also the producer for the physical products. The partners are then OGS, the National Institute of Oceanography and Applied Geophysics in Italy, which is responsible for the production of the biogeochemical products. HCMR in Greece, the Hellenic Center for Marine Research, producing the wave product. And we are all supported by Cineca in Italy for the operational production. So in total, we are more or less 40 experts producing these modeling data. But first of all, why do we need numerical model products? We have already seen the fundamental importance of observations, but both in situ and satellite observations are limited in space and time, as you can see from the pictures there. So numerical models can describe, thanks to the integration of numerical equations, the time evolution of the three-dimensional properties of the ocean, being so given a four-dimensional, so time plus 3D picture of the whole basin. So the model can cover the entire basin from the surface to the bottom at a predefined resolution at a certain frequency in time. But all the available observations from in situ and satellite can be ingested and assimilated by the models in order to provide better solution, thus giving analysis data. Those analysis fields are our best initial condition for the ocean model forecast, which in our case cover the 10 days in the future. You can find as well our products on the Copernicus Marine Catalog, are freely available for any user registered on the website. You just select the Mediterranean Sea area and you will end up with 6 modeling products, which are all provided at a resolution of 4 kilometers, 1.24 resolution. We have 2 products for the physical component, 2 for the waves, and 2 for the biochemistry. Why 2 products? Because we deliver near real-time data, which are an estimation of the ocean properties for the recent past, the present, and the near future, which cover the entire basin. So we provide analysis for the previous 2 years, assimilating observations, and forecast for the following 10 days. Plus a reanalysis products. Those are multi-year products, are a retrospective data assimilative estimate of the ocean, which are additionally integrated by interim time series, which cover the period starting from the end of the reanalysis up to the month -1, so a concatenation. Assimilating, in this case, near real-time data. So these 3 modeling systems, physics, wave, and biochemistry, are all aligned. They are jointly developed. They share the same bathymetry, the same grid resolution, and the same forcing fields. I'm going to show you each product with some information on the modeling system which produce this data. In the case of the physical analysis and forecasting product, we use an hydrodynamic model, which is NEMO, 2-way coupled with the wave model WaveWatch 3, the same resolution, 4 kilometers. And the hydrodynamic model, so NEMO, is also assimilating, thanks to an ocean VAR data assimilation 3D VAR scheme, satellite sea level anomaly data, and in situ temperature and salinity vertical profiles. Of course, a model needs to be fitted by several external forcing fields, such as atmospheric fields, which are in this case provided by ECNWF, which is the European Center for Medium Weather Forecast, at the highest resolution available now, which is 1/10 of a degree. We also provide 39 river inflow, river runoff, and we have 2 lateral open boundary conditions, one in the Atlantic side and one in the Dardanelles Strait, which are provided by the Copernicus Global Analysis and Forecasting System. In the catalog, you can find several variables: 3-dimensional temperature, salinity, and velocity, and 2-dimensional sea surface height, bottom temperature, and mixed layer depth. And if you're not familiar with it, the mixed layer depth is considered the depth at which the physical properties, such as salinity, temperature, and density are well mixed. Those data are provided for the previous 2 years up to 10 days in the future as monthly mean, daily mean, and also hourly mean. The potentiality of the forecast is, for example, depicted here, where I show you a time series of the model sea level in front of Venice. Up to a certain day, up to today, we can have information of the sea level from tide gauges observation. But for the future, we can have some prediction of the sea level thanks to the modeling forecast. I move now to the reanalysis product, again for the physics, which is based on the same hydrodynamic model NEMO. In this case, we have no coupling with waves and no tides are included in this modeling system. We still assimilate sea level anomaly and temperature salinity data, in this case, reprocessed data, so the best available observation. And the forcing fields are, of course, coming from reanalysis for atmosphere, ERA 5, and reanalysis for the lateral boundary conditions. We deliver the same products, which are 3-dimensional temperature, salinity, and currents, and 2-dimensional sea surface height, bottom temperature, and mixed layer depth. To show you the importance of this long time series, in this case from 1987 up to the previous year, I show you here a time series of the sea surface temperature from the model with respect to the satellite observation, which shows you the quality of our product and the importance of the reanalysis in, for example, providing a monitoring of the Mediterranean sea content that you can see in the bottom picture, showing the positive trend from different reanalysis in our basin. I move now to the wave analysis and forecast product. These data are provided by means of a VAM spectral model at the same 4-kilometer horizontal resolution. It includes 32 frequency in 24 directions. We assimilate a significant wave height from satellite data from Copernicus TAC. And again, we have the same atmospheric fields as ECNWF. And the sea level and surface currents are provided by the physical near real-time system that I've just presented, while the lateral boundary conditions are from the global Copernicus wave system. A long list of variables can be retrieved from the catalog from the previous 2 years up to 10 days in the forecast, mainly for the significant wave height, the wave period, and the wave direction, for the wind waves, but also primary and secondary swells. And here on the right, you can see the validation of this data, an example of the validation with respect to in situ data in the top panel with respect for the significant wave height, and at the bottom for the mean period, showing you the very good scale of this data. The wave reanalysis product is based on the same numerical model VAM, in this case assimilating reprocessed data and being forced by reanalysis field. You can find the same model data from the catalog. Here a difference with respect to the near real-time system is that the lateral open boundary conditions are provided by the a lower resolution wave model run at HCMR. And to show you the usage of this product, It can be used, for example, to retrieve extreme variability for the significant wave height in the Mediterranean basin. And here you see an example of the mean annual 99th percentile of the significant wave height, showing the area where the significant wave height is larger in the period, and also a comparison with respect to in situ data, which are the ones in the circles. I move now to the biogeochemical product. The analysis and forecast is based on the OGS transport model combined with the biogeochemical flux model, BFM, which simulates the dynamics of the marine microorganisms such as phytoplankton and zooplankton, which are the so-called lower trophic level, and the related biogeochemical cycles of inorganic matter, which are carbon, nutrients, and oxygen. Here we assimilate, thanks to the 3D VAR bio data simulation scheme, both chlorophyll from satellites, but also chlorophyll and nitrates from in situ floats. Again, the atmospheric forcing are from ECNWF. We have 39 river inflow, and lateral boundary conditions are here provided by climatologies. A long list of variables can be retrieved from the catalog for this product from the previous 2 years up to 10 days in the future, which are 3D daily mean concentrations of chlorophyll, alkalinity, dissolved inorganic carbon, ammonium, nitrate, dissolved oxygen, pH, phytoplankton biomass, phosphate, primary production, silicate, and zooplankton. And in addition to those, you can retrieve also 2-dimensional daily mean fields of flux and surface partial pressure of carbon dioxide. And this is an example of the importance of this product. Thanks to that, you can, for example, have a look to the meridional and zonal trophic gradients of chlorophyll in the Mediterranean Sea, but also the decoupling between the surface and the deep chlorophyll maximum dynamics, for example, in this case of a summer stratification period. The reanalysis for the biogeochemical product is based on the same biogeochemical flux model, simulating chlorophyll from satellite and being forced with the reanalysis data. I show you here an example of the use of this long time series from 99 up to the last year, in presenting map of mean annual CO2 flux, which show us 3 main areas of atmospheric sink of CO2, which are the North Aegean, the Adriatic, and the area of the Gulf of Lion. But also time series of PCO2 and CO2 flux, showing a net weak sink of CO2 in our basin. Finally, I will give you some information about the quality of our data, which is constantly monitored, and you can have a look to it thanks to the Copernicus product quality dashboard. You just need to go to the user corner, select the product quality, and you will have a look to the time series of root mean square difference and bias for the variable that we delivered. But in addition to that, we have also developed a regional validational website, which every day monitor the analysis and forecast skill of our products. We have websites showing the validation of temperature, salinity, and sea level for the physical product, the significant wave height and the mean period for the wave product, and a list of biogeochemical variables thanks to this InnoGS validation website. The applications of our products are many. They can be used to force high-resolution coastal models, to support coastal monitoring, safety and disaster, search and rescue, marine navigation, natural resources and energy, civil protection, research, blue economy, and many, many others. So finally, this is a recap of the 6 products for the Mediterranean and Monitoring Forecasting Center. You can retrieve them from the Copernicus web catalog. Each of it is coming with the documentation, the product user manual for technical information, the quality information document for the scientific validation. Each product has its own DOI, so please, you can use it for reference. And if you still have questions, please ask us through the user corner. We have fax, a help desk, and the contact us button. Thanks a lot for your attention.
Thank you for this presentation, Emanuela. We have a lot of questions, but as the time is running, I propose you to answer just one, and the other question will be answered during the breakout room session. Okay, so let me share my screen. Yeah. Yep. So the first one is, how could the total phytoplankton biomass in the entire water column be obtained for a given area?
Well, actually, I'm not a very expert in the biogeochemical product. I can ask to my colleague and come back with an answer as in the slide as soon as possible.
Yes, we can answer the question even after the webinar. Don't worry. So perhaps another question about physics forecast?
Yeah.
Yeah.
Sure.
What are the coupling processes implemented in the physics forecast model with the wave model?
Yeah, for the moment being, we have a sort of simple coupling between the hydrodynamic and waves. So the wave model provides only the neutral drag coefficient to the hydrodynamic model. On the other hand, the hydrodynamics provide the surface currents and the surface temperature to the wave model. In the next year, so end 2023, we will have an improved modeling system with also an improved coupling with additional exchanges between the wave and the hydrodynamics.
Okay, thank you. So I stop now the Slido and we'll continue this webinar. Thank you, Emanuela.
Thank you.
So let's move now on the user testimonies part. So we have three use case to welcome now. So let's start with a good example of downscaling on the Tunisian coasts, which benefits institutions and agencies interested in marine environment research and also in the economy sector. I'm pleased to welcome Marwa Ouni.
Welcome. Good morning.
Hello.
Hello.
So the floor is yours.
Okay, I will share my screen. Just a minute, please. I think now you can see my screen.
Yes.
Okay, that's good. So first
Perfect.
of all, I'd like to thank you for giving me this opportunity to present our work in progress using the Copernicus Marine Service products. My name is Marwa. I am a PhD student in the laboratory, Marine Environment Laboratory in the NSTM in Tunisia. Today, I'm going to talk about FOR-MTUN, an operational marine forecasting system for the Central Mediterranean Sea, more precisely for the Tunisia coasts. It provides a 9-day forecast for marine dynamics parameters like sea level, temperature, salinity, current velocity, wave height, and tide. The forecast of all these parameters will be used for many applications, like the management of the fate of any material spilled into Tunisian marine waters. For example, in case of maritime accident or aquaculture discharge, for maritime security and hazards monitoring, like jellyfish blooms, and for red tides, which is an harmful recurrent phenomena along the eastern Tunisia coasts, in particular in Gulf of Gabes, and to support the offshore aquaculture. that is an important economical sector here, and also for fisheries and tourism. Let's turn now to the Copernicus Marine Service products, which are important in our forecasting system because we use it as a model boundary condition and in the model validation. The variables used are temperature, salinity, velocity, and sea level height. From the catalog of Mediterranean Sea Physics Analysis and Forecast and the catalog Mediterranean Sea Physical Reanalysis. In this slide, I will present for you the model used, ENSTM code HD. It is an high-resolution ocean circulation model based on the Princeton Ocean Model, POM. Its domain covers the central Mediterranean Sea and extends from the Tunisia coasts to the eastern Sicily and the southern Sardinia. It has 2 kilometers horizontal grid and 18 sigma layers for the vertical. At the service, the model is forced by forecasts from HCMR, which are hourly for the first 4 days of the forecast and 3 hourly for almost of the 2 following days and 6 hourly for the last days. And for the boundary condition, as I mentioned before, we use forecasts from Copernicus Marine Service, which are hourly for the first 5 days of the forecast and daily for the last days. Now I will briefly explain to you the operational forecasting chain. Let D be the day of the forecast. We will we start by reading the D start condition and download, interpolate, and forecast and force the model by the atmospheric and lateral forcing data. Then the model is run for the next 9 days, and we generate the restart condition for the next day. That means the day, the D+1 day. All this procedure is repeated every day. What's really important here is that all these steps are full automatic. Now, let's show you some results from a hindcast test over the period of May from 11 to 19, 2021. In this test, the initial conditions are from Copernicus Marine Service. This figure illustrates the time evolution of the SST for the entire model domain. The red line refers to the model forecast. The green line refers to the forecast provided by Copernicus, and the blue line refers to the reanalysis provided by Copernicus. As you can see, the model forecast is close to the forecast and even the analysis from Copernicus. These two figures illustrate the SST, the horizontal distribution of the SST. In the right is the model forecast, and in the left is the forecast provided by Copernicus. For the 15th May at 9:30 o'clock, we note that there is a good correspondence between the two forecasts, but by zooming on the Gulf of Gabes, that means this area, we observe some fine structures simulated by the model, which are resulted by our high resolution. To evaluate the forecast, we do some statistical tests. For example, we calculate the RMS error of the SST between the forecast of the model and the forecast provided by Copernicus. As you can see in this figure, the RMS error are low in almost of the area, except some location in the north and especially in the Gulf of Gabes, which are shallow area. Currently, we launched the 6-month forecast chain from December 2020 to May 2021. It is a hindcast test for evaluate the forecast performance It is full automatic, even in case of missing input data. To complete this chain, we need nearly 19 days. And for the forecast mode, as you all know, we need to download the forecasting, the FOR-MTUN data each day. So we start by downloading the atmospheric data at 7 o'clock and the marine data at 16 o'clock. The interpolation of this data and the run of the model lasts 2.5 hours. Then the forecasts the model forecasts are made available at 20 hours. This brings me to the end of my presentation, but before that, let me tell you about our future work. In the near future, we plan to increase the resolution for better simulate the circulation close to coastless. Our goal is to reach 500 meters. Then we will use observation from ferry box for the data assimilation. The ferry box is the system installed in board of a ship in order to measure automatically and continuously some marine products. For example, in our case, we will use the 3D temperature and salinity from 2 trucks from Tunis to Marseille and from Tunis to Genoa. Also, we will use forecasts from Copernicus Marine Service to assimilate the model inside the domain, but that of course will be for a very large scale. Then we will prepare our web portal for FOR-MTUN, and we will start sending early warnings and alerts. Then we will progressively incorporate some new components like runoff, transport of the solvent, and particulate material. And for the long-term future, we plan to add the submodels to the operational system, like the biogeochemical submodel and the runoff submodel. And that's all. Thank you for listening.
Thank you very much, Marwa.
Thank you, Marwa. I propose, because we are a bit late, I propose to keep the question for the breakout room for the extra session after all the presentation. Okay?
Okay, thank you.
Thank you.
So we now go on with our second use case. We're now welcoming Daniela from Planetek, and she's going to present her activity. Hi, Daniela.
Hi, thanks a lot for inviting me.
You're welcome. The floor is yours. You can share your screen. Thank you.
Okay. Today, we're going to present you a pilot that we developed for Taranto Port Authority in the frame of Impressive project. Impressive is an H2020 funded project aimed to develop a portfolio of services think to address the marine pollution events in the port surrounding water. As I mentioned, today I will speak only about the pilot that we did in Taranto, in Italy, but during the project, other 2 pilots was done, one in Rafina port in Greece and another in La Luz in Canary Island. Here you can see the home page of the Impressive geoportal, where the user can enter after an easy registration. And here you can find 2 specific services, one for oil spill and another for wastewater. Here are some details about the 2 services. For what concerns the oil spill, this is a totally automatic service based on Sentinel-1 data. The service started when an expert system developed by the National Observatory of Athens collect Sentinel-1 data passing over the area of interest and classify any potential suspicious object to be an oil spill, giving some parameters. In particular, the most important is the probability of occurrence. All these potential oil spill are collected in a database and sent in real time in the GeoPortal platform. The user can check these events and display on the map. When an event has a probability of occurrence higher than the 50%, in this case, an early warning system delivers an alert to the end user by email. And in the meantime, a forecast module delivers forecast oil spill drift for the 3 days after the event date. Again, this system works in totally automatic way and is working since June 2021. The second service is instead dedicated to the monitoring of the wastewater. In this case, the main data that we are using is the Sentinel-2 optical data and some Copernicus marine products. Also, this service works in totally automatic way. And there are, on the area of interest, the provision of some products such as chlorophyll, suspended particulate matter, and turbidity provided by satellite, and some products provided by modeling that are the sea surface temperature and the current, both in intensity that in direction. As I mentioned, we used some Copernicus marine products for the implementation of this pilot. Essentially, for the oil spill service, we used a forecast product for the implementation of the forecast model. And for what concerns the wastewater service, we used some water quality parameters, in particular the ocean color near real-time data and the sea surface temperature. This project is designed essentially for port authorities, but of course there are other user categories that can benefit, such as shipping companies, local and regional public authorities, coastal guards, environmental protection agency, oil and gas industries, and offshore industries. During a final conference that was done in last October, all these user categories were present and discussed in a dedicated round table about their needs and about the benefit of using this kind of services based on Earth observation. Essentially, main benefit are the opportunity to have an integrated solution for the oil spill monitoring in the harbor area, to have a methodology that is validated in numerous research projects and is based on Earth observation consolidated products, to receive an alert when suspicious events occurred in the area, and most important, to access to a cloud user-friendly platform that did not require to install any software, any plugin, but also user did not have some prerequisite of knowledge in Earth observation data. So it's really thinked for managers, for decision makers. Here, the project ended at the end of 2021, but the project partners are really active because we are doing some promotion activities for the services developed in the project. And we are open to discuss with other potential cooperating projects. Before to end, just to close, I mentioned only the oil spill, only the earth observation and modeling services of this project, but there are also other services based on the use of drone and autonomous vehicle that were totally implemented and validated during the project for La Luz. Thanks a lot for your attention.
Thank you very much, Daniela.
Thank you. As the previous presentation, I think we will keep the question for you for the extra session. Thank you very much. So let's now move to the last user testimony. So I don't know about you, but when I go swimming in the sea, I'm always afraid of finding jellyfish. When there is a high concentration of jellyfish in an area, it can be a serious impact on fishing, tourism, and aquaculture. Fortunately, ColomboSky has developed a tool to monitor jellyfish swarms and their drift, and I'm very pleased to welcome Federica Colombo from ColomboSky.
Good day, everybody. Thanks so much, Fabrice, for your introduction, and thanks to both Mercator Ocean and Noveltis for inviting us today.
Thank you.
Okay, I'm just going to share the screen. Okay, so as already introduced, following the introduction of Fabrice, today we're going to talk about JellyX, which is an ocean monitoring tool to predict jellyfish swarms. My name is Federica Colombo, and I'm a marine scientist at ColomboSky. That is a technology company that develops ocean monitoring systems based on satellite technology and artificial intelligence. We specialize in aquaculture, but we're also working with developing tools for other ocean-based industries. As already said, jellyfish are a known problem for bathers, but it's not just their stinging power that poses a threat to the ocean, but also they can represent serious threats for the blue economy. For example, they can lead to collapse of fisheries because massive aggregation of jellyfish can deplete completely a fishery by feeding on larvae and juvenile fish. They can also cause the clogging and cooling systems in power plants. And also this causes power disruption, so no electricity for a while, closure of plants, and serious damage for this industry. A similar problem is also posed to the desalination plants, which translates into freshwater disruption. Jellyfish aggregation can also invade fish farms, and since the fish that caged, they cannot move, they can get killed directly from the stinging, or indirectly by secondary infection produced by the urticant cells on the tentacles of the jellyfish, but also because of the stress that these animals create, the aggregation creates, and when the bloom dies, the decomposition burns actually oxygen, and therefore they basically die for asphyxiation, which of course also translates in massive losses for this industry. Last but not least, as you all know, it can create serious injuries to tourists and beachgoers, and some cases also of kills of people have been reported. So So it is a very serious problem, and is also very challenging to study this phenomena because jellyfish have very rapid reproduction rates. They can reach thick densities in a limited time period. They have very different life histories because what we call jellyfish is actually a bunch of very different animals put together. So it's not just the classic medusa, which are cnidarians. They're also called jellyfish, tunicates. So all these animals are very different from the phylogenetic point of view, and also for the way they reproduce and the ecological niche they live in. Another challenge of studying jellyfish is represented by the limited survey effort, despite in the last years a lot of citizen science campaigns have been launched, trying to involve citizens to collect data that can provide useful information for those that study the problem. And a lot of advances has been made, but still people generally log their observation while they are at the coast. So we don't know exactly what is happening in the middle of the sea, for example. It's also difficult to parameterize the physiological rates of these organisms and therefore try to model them in order to forecast, for example, the phenomena. And there's a high uncertainty about the population dynamics. In fact, we assist to massive blooms one summer, and then the summer after, maybe we don't see any of them. So nobody really understands exactly the population dynamics of jellyfish. So since we already had some success in developing forecasting tools for hazardous phenomena in marine environments, such as harmful algal blooms, we decided to give it a go and try to sort out this problem, or at least address some of the challenges related to studying jellyfish outbreaks. And all this led to the creation of JellyX, also thanks to the support of the Copernicus Marine Service. JellyX is a jellyfish monitoring and forecasting service that is integrated into AquaX platform, which is our core product. It is an online monitoring platform developed mostly for the aquaculture industry that gives the opportunity to monitor a wide set of environmental parameters of interest to the fish farmer, but not only to the fish farmer. It provides the detection and mapping of the risk of jellyfish outbreaks expressed in density of the aggregations. It is based on forecasted environmental parameters that are known to favor jellyfish proliferation. And these environmental parameters are achieved through satellite data, proprietary oceanographic models, and artificial intelligence. The JellyX service provides daily risk maps categorized in 3 classes, depending on the risk and the density of the jellyfish individuals per over an area of 10 square meter. Gives the opportunity to set automatic alerts that work on today's forecast. So the user can select an area and set the threshold at which he wants to be alerted, close the computer, go to bed, and he will get automatic alerts 2 days in advance on the threshold parameter he set. This works for the jellyfish risk, but also for the other services integrated in the AquaX platform, which also provides the user with the possibility of inserting a logging his own observation in order to improve the accuracy of the prediction algorithm by feeding the system with additional data, which is a very cool, very useful application of our system. We developed this service for the Mediterranean Sea, where it's actually running over 12 jellyfish species, which are the ones that are known to form bloom and are the more common in the area. But most of these species are also cosmopolitan species, so they live pretty much everywhere in the oceans of the world. So we are confident that we can deploy the same system by adjusting it to any area of the world where this problem shows up. At the moment, we always we have an average prediction always higher than 75%, which is pretty good. And the benefits for users of the service are, of course, large-scale daily monitoring. So the user can monitor not just the area where he works in, but the whole water basin. AquaX also provides easily interpretable data to monitor, manage, and prevent the impact of jellyfish outbreaks by the forecasting power. Thanks to the forecasting power, the user can also effectively manage the risk by applying the appropriate mitigation strategy per time, thanks to the alert per time. And this allows the prevention of major damages and particular revenue losses that for all the operators working in the ocean, that is very important because the environmental risk is always there. And another additional benefit is that there's no need for instrument deployment in the water, which is costly to maintain and also laborious, or software installation because the platform runs completely online and can be accessed through any device also remote. The products of Copernicus Marine Service that we exploited for the development of the service are these ones that you can see on the slide. Thanks to leveraging these products, we managed to provide a large spatial and temporal coverage of our service by using valuable ocean data and also their forecasts. Another additional benefit of this service for our activity is the provision of scientifically validated data and ocean models. And the fast download makes it a reliable source of data for our application. Before closing this presentation, I'd like to present a little case study that we prepared a couple of years ago on a bloom event that happened in Israel. So in summer of 2020, there has been a massive bloom of Ropile manovadica, that is a big jellyfish of Lessepian origin. So they came into the Mediterranean Sea from the Suez Canal and occasionally creates bloom in that part of the Mediterranean. So in that summer, there's been a massive bloom of this jellyfish that generated suspension of the service of the Rutenberg power plant in Ashkelon, Israel. So there was no major damage to the power plants, but they had to shut it down for a while to allow for the cleanup because all the jellyfish got into the piping of the cooling system. And therefore, without shutting in, they would have got major damages. So we pointed JellyX on the area to see what its prediction capability was for the area, what it was saying, what kind of information was giving us in that time. And this is what we saw. So on the 8th July, everything was nice and green, so no risk of jellyfish bloom and 0 individuals predicted. On the 9th July, which is actually the day of the event, we can see all this red area is the area where the JellyX predicted high risk for jellyfish aggregation, and yellow these other parts. So that pretty much is what actually happened, for then being reduced the day after. So if these guys had the chance to use JellyX and to have it deployed on the area, they would have got an alert 2 days before, so on the 7th of July, when the risk was low and there was no jellyfish around. So yes, it was just to show how this tool actually works in practical time and the benefits that it can bring to ocean-based industries. So thanks again for having us today, and thank you very much for your attention.
Thank you, Federica, for your very interesting presentation, very useful as well.
Thank you, Federica. You have a lot of questions on Slido, so I propose you to answer during the breakout group. And I feel better now. I can go swimming with confidence. Yeah. Thank you.
So we're now going on with our very last lecturer, Cedric Giordan, who's going to present us the user corner and e-learning material. Hi, Cedric.
Hi, Ergane. Thank you for the introduction. Hi, everybody. Nice to meet you. So I'm Cedric from Mercator Ocean, and I manage a user support team of the Copernicus Marine Service. I will give you a short presentation of the user corner. So it's an area dedicated for users, in which you will find several useful links. I think this moment there is a sound issue, no? I can see Dark Vador. So
please mute the participants.
I don't know if you hear the same thing like me, but it's okay, I think. Yeah, yes. You should see the main page of the website. And to reach the user corner, there is a link on the menu here, user corner. So there are several sections. The first one is the getting started page. It is the first page to visit because you will find a sum up of the offer and an operational path to discover and to manipulate our services and data. So there is a search section, visualize, download data, be informed, learn, and if you have any question, many useful links are available. So don't hesitate to use them. To come back to user corner, the second section is as well a very, very important section because it is a link to the Help Center. In this Help Center, you will find more than 120 articles on several subjects. They are sorted by a collection. You can search by keyword, for example. Here I can see the article, how to be informed of operational events on products and services. I will show you after why I've chosen this article. So in the article, you have the timetable and you have sometimes videos, sometimes step-by-step, depends on the article. And so everything is useful to use the services. I come back to the user corner. The user notification service page. In this page, all the operational events are listed. So improvement, incident, maintenance, and general. So there are 4 different tabs. For example, I go to the maintenance. Here, we know that on the 23rd of May, there will be a maintenance on the sea-level NRT products. So I click on the title. I have the product impacted, of course the period, and something with really interesting is this search area, because you can define your search and you can create your own RSS feed. And when your RSS feed is created, you can go to the article see before, this one, and you can know how to retrieve your RSS feed to be informed automatically in case of maintenance, incident, etc. Because you can do the same thing for the incidents and for the improvements or general. So for example, if I go to improvements, I can see there is a notification about the next release of the Copernicus Marine Service, which is planned on the 5th of July. So you click on the title, there are two different documents, a notice, so the perimeter of the release, and then all the product impacted by release. So don't hesitate to use these RSS feeds to be informed of anything operational events on the Copernicus Marine Service. I come back to the user corner. The user learning services. Here you will find all the scheduled or past events on the training workshop, etc. So, for instance, you have the link to the current workshop. The e-learning materials, here. Here you will find different materials, script, notebooks, etc. You can use to. They are sorted by level, beginner, intermediate, advanced, by subject, and by tool. So everything, there are 4 pages of materials. So it's important and useful to visit this page. The product quality. Yes, okay. So this section is dedicated to monitor the quality of the products. You can sort by area. You can as well sort by the color of the ocean. So blue for physical, green for biochemical, and white for sea ice. And so I'll let you discover of all what is available on this section. So it's dedicated for the quality of the products. The product roadmap. So we saw before a notification on the about the short-term improvements. In this section, you will find mid and long-term improvements. So it's important to note that this page is still under improvement. So to have information for mid-term, it's this page. To have information for short-term, it's more notification in the improvement section of the user notification service. Get inspired. It is a section dedicated for use cases. You can sort by region, country, market. For example, if I choose the Mediterranean Sea, you can see here the different use cases you have heard about before. You click on the thumbnail, and you reach the page with an overview of the application, the products used, and the benefits for user, and the useful links. So the links to a link to the application or the program. A collaborative forum. So this forum is under construction, improvement or construction. So it's not. I won't show. I won't show it now, but it will be available soon. A link to the registration form. It's difficult to say that. So to download the products, you have to be registered, but whatever the application, the data will remain free. So don't hesitate to register. The form is a short form. You put your first name, last name, the email address, the country, the kind of organization, the name of the organization, and the website address, the blue markets. You accept the privacy policy and the terms and conditions, and you can create your account. So check your spams, because you will receive an email to confirm your email address. And then after this confirmation, the registration is automatic. So it's easy and so don't hesitate. There is as well a FAQ section. So it is the same thing that for the Help Center, but for more general question. So there are less questions, but it's a useful section. The service commitment and license. So here you will find a summary of the key points associated with our service. So at the time the user service, the user support need to answer, etc. Everything is written in this document. And the last section is the contact us form. You give the information requested, and you can upload the file, and then you submit your form, and the user support team will be informed automatically and will answer very soon. Another way to contact the user support here is the chat tool here. I click on the bullet, and so it's in French because my brother is in French. But the first section here, it's a direct link to the Help Center. So I click on the search area, and I can, for example, if I want to search the same thing, how to be informed, I click here, and the article is displayed here directly on the browser. So it's very useful. And if you don't have the answer, sorry, there is a problem. If you don't find your answer in the Help Center, you can directly contact us, and you will meet a member of the team. So Chloe, you will see her tomorrow for the demonstration of the viewer, or David, or Elena, or Martin, etc. So don't hesitate to contact us. The team is really friendly and efficient. So thank you very much for your attention.
Thank you, Cedric. So you will be able to ask your question directly to Cedric and a colleague of Cedric in the breakout room dedicated to the user support. So let's move to the last presentation. This is the workshop day 2 agenda by Ergane. Let me share my screen. I am always looking for the button. Okay, I'm ready.
Okay, great. So tomorrow at 9:30 CEST, we will have the workshop day 2, which is dedicated to practical exercises. So we're going to present you several tools for you to use the Copernicus Marine Service products. So we first are going to present you exercises on Jupyter Notebooks and Python. And so we have 2 exercises that have been prepared, one dedicated to beginners. So this is what this slide shows. So the aim of this first exercise will be to show you how to access the Copernicus Marine Service products, how to use the netcdf files within Python, and how to create basic figures, so maps, time series, etc., to visualize the data. So here we have maps of the chlorophyll concentration, time series, and vertical slice. So these are examples of what we will learn to do tomorrow in the first exercise. Fabrice, if you can, yes, thank you. Then we will have a second exercise on QGIS, which is going to be dedicated to advanced users and covers a real case scenario, which are the marine heat waves in the Mediterranean Sea. So we will learn how to detect the marine heat waves and how to calculate statistics. These are the maps at the bottom of the slide. So to calculate the number of days of marine heat waves during a period, the average maximum intensity of a marine heat wave, the number of marine heat waves, etc. So plenty of information you will learn tomorrow. As Cedric presented before, we will also have a presentation of the My Ocean Viewer, which is used, which you can use to observe the data. So yeah, very useful tool as well. And And finally, we will present you some exercises on QGIS. As well, we are going to have 2 exercises, one dedicated to beginners and one advanced exercise. In the exercise for beginners, we will learn as well how to access the products, how to install QGIS and the plugin netcdf to GIS, which is used for, well, to use netcdf files within QGIS. And you will learn how to create maps and animations in order to monitor a medicane. So a medicane is a hurricane in the Mediterranean Sea. And finally, the last exercise, so the advanced exercise, will show you how to monitor an upwelling event in the Adriatic Sea. So that's it for the agenda of tomorrow's session. It will start at 9:30 CST. So I hope I will see you there.
So the simplest is to start by the Jupyter notebooks, no?
Yes.
Yes, okay. I mean, for the people who don't know how to play with the data,
I think my Ocean Viewer is the easiest, yes.
You can start with the My Ocean Viewer, and then you can jump on the first Jupyter Notebook for beginners. And for those who are familiar with the Jupyter Notebooks, on the user corner of the website, you have e-learning material with a lot of Jupyter Notebooks available from the previous training workshops on the Mediterranean Sea. So thank you. Now it's time for the extra session and to move on the different breakout rooms. So yes. So you have different breakout rooms accessible on your menu bar at the bottom of the Zoom platform. And so there is a room dedicated for satellite products, another for model products with Emanuela and Simon Boitard, in situ observations with Maria, moderated by Ergane, room with the user support with Cedric and Chloe, and all the invited people from the user testimonies will answer your question on the user testimonies breakout room moderated by Roman. So I think we will open the breakout room for 15 to 20 minutes. So let's jump to the breakout rooms. See you. Okay, so we are now back in the main room.
Just Fabrice, sorry, Maria, you were answering a question, but you will have plenty of time at the debriefing session to continue your answer. I'm sorry for this.
Just notify the person that I will answer at some other time because
yes, okay.
Okay, thank you.
Yes, sorry, Maria, for this sort of cut, a strict cut at the end of the breakout room session. So before we finish this workshop, I hope to see you tomorrow for the practical session. It would be very interesting to see how to use the data through Jupyter Notebooks and QGIS tool with Ergane and Simon. And I invite all the participants to open their camera if they want to say hello and goodbye, in fact. See you tomorrow.
Stop sharing your screen.
Yes.
Yes, great.
So hello, everyone. So it was a pleasure to have you on board for this training workshop for Mediterranean Sea, and see you tomorrow for the practical session. Don't hesitate to contact the user support if you have questions, and all the material will be available on the Padlet also. So see you tomorrow. Bye, Ergane.
Bye.
And thank you to all the experts.
Bye, everyone.
Bye. Bye. Thank you.
Bye bye.
Bye.
Bye bye.
Bye.
Bye bye.
Bye. I will stay to close the session. Bye-bye. See you.
Bye.